In the last study guide, we looked at reporting and classifying qualitative observations that we might get in the lab. A qualitative observation would be something that is observational. So maybe like a physical property, a chemical property, things that we observe in the lab. The second study guide here is going to be on reporting numerical data, quantitative data, data that refers to a specific quantity that was measured in the lab. Good stuff, right? And again, like the last study guide, I'm hoping that a lot of this is review for you. I'm hoping that this is not the first time you're hearing of the metric system. Now, unfortunately, a lot of what we measure in the United States is still based on English measurements. We still use a lot of gallons and pints and quarts, feet and inches and miles. But a lot of our measurements in the chemistry lab will be metric. So we do need to review the metric system. And the metric system is not supposed to be difficult, but for some reason people kind of suck at it. And this is always one of those things where, like, you might have to make a metric conversion in, May. Maybe you got to switch from liters to milliliters, and all of a sudden people turn into boneheads. Like, well, what the heck is a metric conversion? I know you have done this, maybe not over the summer. So hopefully just a mild review will bring it all back to you. In the metric system, everything is based on these prefixes. These prefixes can make our measurement more appropriate for whatever we might be measuring. If we're measuring something very small, we can put a prefix in front, and maybe we'd say we're measuring centimeters or milliliters. If we're measuring something very large, maybe we'd measure it by a kilogram. So we have our base unit, which I'm going to insert that in here. Right in here. Let's insert the base. The base unit would be like the gram, the meter, the liter. And from there, again, we'll just put a prefix in front to make it more appropriate for what we might be measuring. And obviously these metric prefixes range quite a bit. We've got giga, mega, which would be like a billion or a million, all the way down to nano and pico, which are crazy, 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 crazy tiny. Of these prefixes, the one that you need to be familiar with, I should say the ones that you need to be familiar with are these guys. If by chance nano comes up, which it might, we might be talking about like wavelengths of light or the mass of an electron. And it's super crazy tiny, so then we might put like, maybe we'd say a nanometer or a picogram or something that would represent a quantity that's very, very small. But if that's the case, we can just look those up. The ones that we use more often are kilo through milli. A kilo means 1,000. So if you say you have a kilogram, you have 1,000 grams, 10 to the third. Hecto is 100. People always remember that one, right? Hecto 100. The ones that they sometimes miss are deca and deci. Now the deca is symbol DA. That one means 10. That's the bigger one. Deci is 1/10. Okay, so deci is small. Now a couple things. This deca, here they have it spelled D-E-K-A. It could also be D-E-C-A. Either are totally acceptable. And then here's how I remember them. Look at the little ones. Deci, centi, milli. Deci is 1/10. Centi is 100th. Milli is 1,000th. All the little ones end in I. So that's kind of how I remember it. Deci, centi, milli, deci. Oh, that must be the little one. That's 1/10. Deca, that's the bigger version. That's 10. So if you said you had a decagram, you mean you have 10 grams. If you say a decigram, you mean that you have 1/10 of a gram. These are super tiny. For example, like a milliliter. A milliliter is 1,000th of a liter. 1,000 milliliters would be equivalent to 1 liter. Oh, okay, it's all coming back to me now. I remember the metric system. So a couple things. When we make metric conversions, there are a few options. One option is kind of this ladder method. I like this. I do this, where you will start with the base in the middle. And again, the base is like a gram, a meter, or a liter. And from there, you do need to understand and memorize, I guess, the order of these metric prefixes. Deca. I'll use the C version. I see that more often. Deca is DA. It means 10. Then you'd have hecto. Its symbol is H. It means 100. And then finally, kilo. Symbol K. It means 1,000. From there, we can go smaller. And we'd have deci, which is symbol D, which means 1/10. Centi, symbol C, means 100th. And then finally, milli, the tiny little milliliter, milligram. Symbol M, 1,000. I know, kind of like the deca thing. Milli could be spelled with 1 L, 2 L's. Either is totally acceptable. When I have to do a metric conversion, sometimes I write this on my paper. Now, I write like an abbreviated version, but I have this committed to my long-term memory. I can go kilo, hecto, deca, then comes the base. Centi, oopsie, deci, centi, milli. I have that committed to my long-term memory. And now you can think of whatever mnemonic device you want to remember it, but I will always remember that order of bases. And that makes a metric conversion a snap. All you have to do is find the unit that you're starting with and the unit that you want. So for example, this would be a deciliter. I want to go from deciliter to hectoliter. Deci to hecto. 1, 2, 3. Okay, so in order to go from deci to hecto, I need to move 1, 2, 3 spots to the left. That's exactly what you do with the decimal spot. So if you start with something like 42.6, you're going to move the decimal place 1, 2, 3 to the left. If you run out of numbers, we'll just add a 0. So this becomes 0.0426 hectoliters. Does this number make sense? Yeah. I mean, a hectoliter is a larger quantity. So if I have like 42 little deciliters, that's going to be a fraction of a hectoliter. That's it. That's all there is to making a metric conversion. So again, if I have this written down on my paper, like kilo, hecto, deca, base, deci, centi, milli. And again, whatever mnemonic device you want to use to remember it, I've seen some creative ones. Then all I have to do is find where I'm at. I'm at kilo. I want to go to milli. 1, 2, 3, 4, 5, 6. I'm moving the decimal spot 6 places to the right. So it started as 0.057. Now goes, oh boy, 1, 2, 3, 4, 5, 6. And again, any extra spots will just become zeros. The zeros in the front I can drop. I don't need those anymore. So I'll have 57, 1, 2, 3. 57,000. And again, I can check and see, does this make sense? Well, of course it does. I'm going from kilo to milli. I mean, millimeters are tiny, tiny, tiny. So there should be a lot of millimeters in this 0.057. 0.57 kilometers, or kilometers, whichever you prefer. That's all there is to a metric conversion. And again, I'm hoping that this is something that comes back to you. This is my preferred method. I remember the order of the bases, and then, sometimes I can even do it in my head. Flip the decimal spot. Another option is this proportion method. I'll show you what it looks like. Take it or leave it. You could set up a proportion. You start with what you have, 390 grams. We're going to set up a proportion. The unit that you start with will go on the bottom because you want it to cancel. The unit that you want goes on the top. So this is going to be like grams times kilogram divided by gram. So eventually grams and grams will cancel. Now what goes on the line is the conversion or the relationship between kilogram and gram. Oh, so you could say 1 kilogram is 1,000 grams. And then again, this gram on top, gram on bottom would cancel. And you basically just multiply across and divide on the bottom. So you take your 390 times 1 divided by 1,000. Oh, okay. So if I do that, I would get 0.390. Is that the same thing I would get if I flipped the decimal spot? Absolutely. I just got to either remember the relationship between kilograms and grams, or I have to do this. Kilo, hecto, deca. Then comes the base. Deci, centi, milli. If I went from grams to kilograms, grams is like the base. I'd be moving her, well, what do you know? 1, 2, 3. 3 spots to the left. Now again, if you had this original number as 390, and you're like, but there's no decimal spot, you can add one. You just add it right at the end. And then you'd go 1, 2, 3. There's your decimal. Oh, well, what do you know? Same thing. So it's totally up to you, whatever you prefer. I think flipping the decimal is just quicker and easier. So if I were at hecto and I want to get to centi, hecto, 1, 2, 3, 4, centi. I'm moving the decimal spot 4 places to the right. So it started as 0.78 hectometers. Now I'm going to move it 1, 2, 3, 4. 1, 2, 3, 4. These spots will just get filled with zeros. I can drop the 0 at the front, and this would just become like 7,800. And at this point in the game, I'm not going to take off points, whether you put the decimal spot in or not. We'll talk about the decimal spot later on in this unit. For now, if you're making a metric conversion, if somebody left it off, but they had the answer as 7,800, I would not mark that wrong. Obviously, you can put the decimal spot in as well. So at this point, here's what I would suggest. Pause the video and try some of these at the bottom. Obviously, you see the answer now, but try a few. And then bring back the answers and see if you're getting them right. If you're getting them right, great. These are 1,000,000% just for practice. I'm not going to collect this or grade this. Totally for practice. If you're not getting them right, then that's a red flag that you need to come in for some more help. We're not going to spend a ton of time on something that you've probably done since you were in 5th grade. But again, some people may not have done it as much as others. So I would push pause, try some of these metric conversions at the bottom, see if you're getting the right answer. Hopefully you are, and you are an absolute wizard at making metric conversions.